Welcome to Physics World Online College, where we explain the concept of physics and make it very simple for everyone to understand. In our class of today, we will look at example 4 and 5 as we conclude the topic equations of uniformly accelerated motion. But remember to subscribe if you have not done that, share to others of your friends and fellow students, then comment. At the comment section, I will respond appropriately. Somebody already suggested I should include classwork. As we continue, you can see now there is classwork. So after explaining example 4 and 5, you will do this classwork and then post your answer on the comment section. I will look at it and then tell you if you are right or not. So in our subsequent classes, classwork and assignments will be given. So attempt to them and then give your answers on the comment section. Thank you. I will also advise that as we go from class to class, please have a note where you jot down the concept, the steps, and everything that is being done, so that even before school resumes, you already have a mini note and you have practiced and learned these topics, and then you will see by the time to school resume, you are well informed and better prepared for the new term. So in our last class, we did about 4 statements of facts about motion in a straight line. I want to apply especially the statement number 4. Let me recap the 4 statements again. Whenever a body starts from rest, it means that the initial velocity of that body is 0. And whenever a body comes to rest, it means that the final velocity of that body is 0. Whenever a body moves with uniform or constant velocity or speed, it means that the acceleration of that body is 0. And lastly, if a body is retarding with a certain value, that value in the question given to you will be positive. If the value is positive in the question, but it is retardation or deceleration, then in the solution you must include a negative sign. That is the point I want to drop home as a result of the class of today. So pay good attention as we continue. So let's see solution to question number 4. So solution to question 4. Let's pick what is given to us in the question. A bicycle slows from 108 meters per second with a uniform retardation of 5 meters per second square. The first velocity given is the initial velocity. So we are given initial velocity u as 108 meters per second. Then in the question you are given uniform retardation of 5 meters per second square. Although it is retardation, the value there is positive. But when you want to interpret it in the solution, you have to say retardation A is minus 5 meters per second square. That is the point. In the question it is positive. In your solution you have to indicate with a negative sign because it is retardation or deceleration. Good. They say, how long will it take to reach 18 meters per second? That is the second velocity being the final velocity, 18 meters per second. And what distance is covered. Let's take the first part. How long means time. So time, t, question mark. If you check the parameter that we have here, u, a, v, t, the equation of motion that covers that will be the first equation of motion. So we say from first equation of motion, v is equal to u plus at. We substitute our value. V is 18, u is 108 plus bracket open because there's a minus sign, minus 5 times t. We have 18 equals 108 plus bracket minus 5t. You open bracket with a plus sign, and that sign changes to what? Minus 108 minus 5t. You collect like terms, you have 18 minus 108 cross over to become minus 108 equals minus 5t. Now 18 minus 108 gives you minus 90 equals minus 5t. Divide both sides by minus 5. Therefore, t is equal to minus 90 over minus 5. Minus we cancel minus, we have t is equal to 18 seconds. For us to get the distance covered, we say let the distance covered be s. For us to find s, let's apply the fourth equation of motion. From fourth equation of motion, we have s is equal to half, open bracket, u plus v, close bracket, times t. If we substitute our value, we have s equals half, bracket, open, 108 plus 18, close the bracket, t that we have calculated, 18. That gives you s is equals to half bracket 108 plus 18, 126 times 18. So this gives you s equals 2 divided 126 divided by 2 gives you 63 times 18. That gives you s equals 1134 meter. In kilometer, if you were asked to find the distance in kilometer, you say s equals 1134 over 1000. That takes it to what? Kilometer. And that will give you that distance. S is 1.134 kilometer. So they say we should get the velocity time graph. To sketch the velocity time graph, we identify our axis, velocity in meter per second against time in second. Our origin is always 0, 0. So the body started with initial velocity of 108. So that's at the top. U equals 108 meter per second. And then decelerate or retards. It means the body is coming down. But it does not come to rest. Rather, it reaches 18 meter per second. So you have to suspend it somewhere here. So that gives you V is equals to 18 meter per second. So assuming the body is coming to rest, then you extend it to 0. But it is not coming to rest, not yet. So it is 18 meter per second for the final velocity V. The time taken, as we have calculated now, the time is what? 18 seconds. So the retardation here is A equals minus 5 meter per second squared. The total distance or displacement we have calculated, that's the area of the trapezium. The area of the trapezium given as x equals 1134 meter. So that is the velocity time graph for example 4. So let's look at example 5. Example 5, solution to example 5. You say a motorist is traveling at 90 km per hour. Once again, the velocity mentioned first is the initial velocity, and it's given as 90 km per hour. But you cannot use it in kilometers per hour because we want the retardation in meter per second squared. So you convert it. So we say given initial velocity U equals 90 km per hour, which we convert to meter per second by saying 90 times 1000 over 60 times 60. Once you multiply and divide, you get what? 25 meter per second. Say applies his brake and comes to rest. Comes to rest, that's the statement there. Comes to rest means the final velocity is 0. So this one, it means we say V final velocity equals what? 0 meter per second. What is our reason? Because the body comes to rest. Good. Then we are given the time, they say in 20 seconds. So time T is 20 seconds. So they want us to calculate the retardation in meter per second squared. So we are looking for A equals question mark. So we have to use the formula for acceleration or definition of acceleration, which we use to obtain the first equation of motion. And what is that? From A, V equals V minus U over T. We substitute our values. A equals V is 0, U is 25, and T is 20. You will see that we have A is equals to minus 25 over 20. So you see that the minus sign for the retardation comes out by itself. You don't need to force it. 25 divided by 20, that gives you minus 1.25 meter per second squared. Now, this is the preferred way where I want you to express retardation anytime you are asked to look for it. You will say therefore, retardation minus A equals 1.25 meter per second squared. Why is this so? You will see that so that if they were to express this example 5 in the language of example 4, when they want to mention the uniform retardation of, it would be 1.25 meter per second. because in the question they will not put a negative sign, but in the solution there is a what? A negative sign. That is why you are asked to express your what? Retardation as minus a equals 1.25 meter per second square. Now we have the velocity time graph to sketch, which is pretty simple in this case. We have velocity in meter per second against time in second. Our origin is 0, 0. Now, this body started with a velocity u equals 25 meter per second, and then retards to rest. So it comes to 0 with final velocity here being equals to 0. Then the time for the motion is what? 20 seconds. So this 20 seconds in the time axis. So it is obvious we could have been asked to find the total distance of this body. How do we obtain that? That will be the area of this graph, area of this right angle triangle, or you use any of the equation of motion. Of course, the fourth equation of motion could also have solved it for us. So as part of the assignment or classwork, you can find the total distance, which should be half bracket open u plus v close bracket times t. That will give us the total distance or displacement covered by this body. So please do this classwork and report your answer. I will take care of it or give you or tell you if the answer you have posted is correct. Thank you and God bless you. See you in our next class. This is the end of the topic equation of motion. Bye bye.